Welcome to our channel. Today we're diving into the fascinating world of microorganisms in space. You might think of the cosmos as this pristine, sterile environment, but the truth is, it's teeming with microscopic life. We're talking about the life we bring with us from Earth. How do these tiny life forms, from bacteria to fungi, respond to the extreme conditions of outer space? We're talking about changes in their behavior, their virulence, even their genetic makeup. Understanding these microbial astronauts is crucial for the future of space exploration. Let's kick things off with a familiar face, Escherichia coli, or E. coli. E. coli gets a bad rap down here, often associated with food poisoning. But up in space, it's a star player in scientific research aboard the International Space Station. It's a model organism, making it easier to study how space travel affects its system. Scientists have been sending E. coli into orbit for decades, observing its growth and antibiotic resistance. E. coli gets stressed out in space. It can become more resistant to antibiotics, posing risks to astronaut health. It can also form biofilms, clogging up equipment and causing trouble. Next up, we've got Salmonella typhimurium, another bacterium that's not exactly known for its friendly disposition. Studies have shown that Salmonella typhimurium actually becomes more virulent in microgravity. That means it has the potential to cause more severe infections in astronauts, who are already facing compromised immune systems due to the stresses of space travel. This increased virulence is a serious concern for long-duration spaceflights, where access to medical care is limited. Let's talk about Staphylococcus aureus, or staph for short. This bacterial bad boy is notorious for causing a range of infections, from minor skin irritations to life-threatening conditions like pneumonia and sepsis. Staph is incredibly resilient, able to survive on surfaces for extended periods, making it a concern for spacecraft cleanliness. Researchers have been studying how microgravity affects staph's susceptibility to antibiotics, as well as its ability to form biofilms. Staph, like some other microbial baddies, can become more resistant to antibiotics in space. Meet Bacillus subtilis, an extremophile microbe. It forms tough, dormant spores, making it incredibly resilient. These spores withstand extreme temperatures, radiation, and even space. Scientists test these spores outside the International Space Station. Bacillus subtilis helps study life's resilience. Hold on to your hats, folks. We're diving into the world of Pseudomonas aeruginosa, a fascinating and concerning bacterium. This little guy thrives in various environments, from soil and water to spacecraft. It's notorious for forming biofilms, those slimy layers that wreak havoc on surfaces. In space, biofilms can clog water systems, corrode equipment, and pose health risks to astronauts. Researchers are studying ways to prevent and control these biofilms in space. Hold on to your sandwiches, folks, because we're about to talk about Aspergillus niger, a type of black mold that's found everywhere on Earth from our homes to, yep, you guessed it, outer space. Aspergillus niger can survive in some pretty harsh conditions, including the dryness and lack of nutrients found on spacecraft. It's been found growing on everything from space station walls to the surfaces of scientific equipment. While Aspergillus niger isn't typically harmful to healthy individuals, it can pose a risk to astronauts with weakened immune systems. Let's talk about Candida albicans, a type of yeast that calls our bodies home. It usually hangs out without causing any trouble, but in the unique environment of space, it can become a bit of an opportunistic party animal. Candida albicans is known for causing infections, particularly in people with weakened immune systems. Scientists are studying how Candida albicans behaves in space to develop strategies for preventing and treating infections in astronauts. Meet Penicillium spp, fungi known for their contributions to medicine. They are the masterminds behind penicillin and other antibiotics. But how do these fungal pharmacists fare in space? Penicillium spp can survive and thrive in space. Microgravity can enhance the production of bioactive compounds. Imagine producing essential medicines on space missions using bioreactors. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating insights. We've journeyed through the cosmos of microscopic life, exploring how these tiny travelers adapt and thrive in space. From antibiotic resistance to biofilm formation, we've uncovered the challenges and opportunities microorganisms present for space exploration. And remember, the next time you look up at the stars, consider the unseen world of microbes along for the ride.